If you spend 5 minutes on tech Twitter right now, you'll see the exact same advice repeated like gospel. Stop uploading raw PDFs to LLMs. You're wasting tokens. You're an amateur. Use this new open-source Markdown parser instead. And it feels good, right? You install a shiny new tool. You watch it spit out clean Markdown text in your terminal, and you feel like a senior infrastructure engineer. You just saved 400 tokens on a 10-page document. Give yourself a medal. But here's the reality check: no one wants to give you. If you are spinning up a local parsing server just to extract 3 bullet points from a single product brief, you aren't being efficient. You are over-engineering for dopamine. Today, we are stripping away the hype. We're going to talk about the actual line between hobbyist tinkering and production-grade systems engineering when it comes to dealing with documents and LLMs. Because the truth is, half the data pipelines being built right now are completely backward. They aren't saving time or money, they're just adding latency, failure points, and architectural debt. Let's look at the real math, the real tooling, and where the industry is actually going. Now, let's be fair. The anti-PDF crowd isn't entirely wrong. Raw PDFs carry a massive unseen tax. When you drop a PDF into an LLM context window, you aren't just sending the words on the page. You are sending broken tables, headers, footers, weird page numbering, OCR artifacts, and invisible layout junk. To an LLM, a PDF looks like a messy room. It can find what it needs, but it has to wade through trash to get there. If you are building an enterprise RAG, retrieval augmented generation, pipeline processing thousands or millions of documents, that layout junk isn't just an annoyance, it's a financial hemorrhage. Those useless layout tokens compound. They slow down your response times, they bloat your vector database, and they degrade the model's attention. For large-scale automated workflows, engineering discipline dictates one rule: normalize your data before it hits the context window. Clean structural markdown is the gold standard for this biz. But here's where the nuance breaks down and where the internet advice turns into pure gatekeeping, because not all documents are created equal. The people telling you to just convert everything to Markdown are assuming you live in a world of perfectly clean, digital native text documents. Let's talk about the real world. A cleanly exported PDF from Microsoft Word converts to Markdown beautifully. But what happens when your autonomous agent hits a scanned, multi-column financial report? What happens when a page is rotated 90 degrees, written in mixed languages, or contains nested, borderless tables? If you throw a lightweight text-blind parser at that, it doesn't just fail. It crumbles silently. It spits out a wall of unaligned, out-of-order text that makes absolutely no sense to an LLM. You see, tools like Microsoft's MarkItDown are fantastic for Python native, straightforward workflows, but the moment you hit complex enterprise data, you are just trading one problem, raw PDF overhead, for a much worse problem, conversion quality variance. If you are serious about building document pipelines, you need to understand the trade-off matrix. For speed and simple text-heavy layouts, sure, use MarkItDown or PyPDF. For complex multi-column financial reports with horrific nested tables, you need to step up to something like IBM's Docling or Unstructured, which actually respect layout object detection. For scan-heavy, chaotic real-world mess, you're looking at heavy OCR engines paired with vision LLMs. There is no magic one-size-fits-all script. Anyone telling you otherwise is selling you a tutorial, not a production system. And that brings us to the next massive piece of hype, the Model Context Protocol, or MCP. Everyone is talking about MCP servers right now, connecting things like MarkItDown directly to your AI desktop client, so your agent can read files natively. And look, architecturally, MCP is a phenomenal pattern. It is the foundational infrastructure for the agentic era. It's how we safely wire AI agents to local databases and local tools. But treating it like a casual, consumer-ready feature for everyday tasks, that is a total disconnect from reality. Think about the friction curve here. 1. It requires local configuration, node environments, or Docker setups. 2. The second you move away from a local developer desktop client to a standard web interface like Claude.ai, a local MCP server does absolutely nothing for you without complex tunnel gateways. 3. And worst of all, when you parse documents through an external tool via MCP, debugging happens outside the context window. If the conversion fails, or the tables get mangled, the LLM just gets garbage data, and you can't see why it went wrong. MCP is a developer's power tool for building local systems or enterprise agent gateways. it is not a casual tool for summarizing a 10-page report during your lunch break. So, how do top systems architects actually handle this? Where do you draw the hard line? It comes down to a fundamental rule of data engineering. Document preprocessing must be part of your data pipeline, never something you do at query time. If a production AI agent is running a raw conversion tool at query time, meaning it receives a query, fetches a PDF, runs a parser and then reads it, that is an architectural failure. It introduces non-deterministic latency. It creates a massive single point of failure. If a corrupt PDF enters the loop, it kills the entire execution run of your agent, and you waste valuable compute converting the exact same document over and over again. Here's the blueprint that scales. For ad hoc analysis, if you are uploading a single 10-page report to ask a quick question, just drop the raw PDF straight into the LLM. The platform's built-in parser is highly optimized, it understands visual layouts natively, and your human time is worth way more than the fraction of a cent you save on token overhead. Convenience wins. For production agents and RAG systems, parse once, normalize early, and store the output. When a document enters your system, whether it's a bucket, a database, or a knowledge base, convert it to clean markdown right then. Secure it. Store it in a document or vector cache. Then, when your agent or user runs a query, you feed the LLM the clean pre-parsed data instantly. Zero query time latency. Zero repetitive token waste. Stop letting internet gatekeepers convince you that every quick PDF upload is an amateur mistake. Technology is about trade-offs. If you're building a massive multi-agent orchestration layer that handles high-volume external inputs, yes, go build a robust, layout-aware ingestion pipeline using Docling or layout models. Automate it. But if you're just trying to get work done, use the tool that matches the scale of your problem. Don't build a pipeline when a simple file drop will do. I want to hear from the builders in the comments. Where do you draw the line in your workflows? Are you normalizing everything at ingestion, or are you leaning on the native vision and document capabilities of modern frontier models? Let's talk about it below. Like, if this gave you some clarity, subscribe for deep dives that cut through the marketing noise, and I'll see you in the next one.